Matrices, determinants come out very nicely with, go hand in hand with matrices. So at some point in the future, if you ever deal with matrices, it turns out Cramer's rule was figured out before matrices were even dealt with. This still strikes me as odd. Oh, actually, before I do Cramer's rule, I want to do the same thing here, except with letters. Because this is going to lead to a shortcut for a 3 by 3. So I have A times E F H I minus B times D F G I plus C times D E G H. So this becomes A times EI minus FH plus B times DI minus GF plus C times DH minus GE. Quick scan to see if I did something stupid here. A, B, C, plus minus plus E, F, H, I, D, F, G, I, D, H, so far, so good. I'm now going to distribute AEI minus FHA minus BDI plus BGF plus CDH minus CGE. This distributed. Isn't this so much easier right here? No. Let me point out why this is easier. So if we look at the ones that have pluses in front of them, I have AEI plus BFG plus CDH. Those are my positives. Minus the ones that are negative, I have AFH plus BDI and CEG. AEI. Hey, that's that diagonal right there. BFG. Well, there's BF, and if I kept going, sort of go around the corner, there's G. And CDH, CDH. If I wrote this slightly differently, if I wrote it A, B, C, D, E, F, G, H, I, I'm just going to rewrite the first two columns, A, D, D, E, G, H. AEI is that diagonal there. BFG is that diagonal there. CDH is that diagonal there. The negatives. AFH. Well, AFH is right there. BDI is right there. CEG is right there. So the shortcut for a 3 by 3 is you can either mentally sort of go around the corner or just rewrite the first two columns. Those products minus the sum of those products. Now to Cramer. And I think the Cramer in Seinfeld, I think, was spelled with a K, and this one's a C. They're the opposite, so whichever one is not the Seinfeld spelling. So if I have, well, actually, why don't we go to the problem. I'm going to jump back here. All right. I have these three equations right here. I'm going to write them so that all of the b's, so all the b's are in the first column, all the c's in the next column, d's in the next column, equals, and then the constants on the other side. So I have b plus c plus d equals 0. That's just the first one as is. The next equation, I have negative 6b plus 2c. Take the 12 over equals negative 12 plus 0d. There's an implied 1 in front of those. And the last one, negative 6b plus 4d and then 0c equals, if I take the 12 to the other side, negative 12. So all I've done is just rewrite it into a format. If you're using the calculator, you need to do this too. This is what it is expecting. So first thing is I'm going to create a determinant of the coefficients here. So the first part, I'm going to ignore those. I'm just going to do the coefficients of that. So I have 1, 1, 1, negative 6, 2, 0, negative 6, 0, 4. So I just take the coefficients of B, C, and D once I've got it lined up. I'm going to rewrite the first two columns. 1, 1, negative 6, 2, negative 6, 0. And that determinant, I do that first, so that is 8 plus 0 plus 0 minus negative 12 plus 0 minus 24. So I get 8 plus 36, which is 44. So my solutions for B, C, and D. The denominator is that 44. Now the numerator is what's going to be different between them. And we still haven't used this information yet. So we need to use that information. So the determinant for the B, that's the first column. Instead of using those coefficients, I'm going to use the 0, negative 12, negative 12. So my numerator here is going to be the determinant of 0, negative 12, negative 12, and then 1, 2, 0, 0, 1, 0, 4. So I'm going to end up with 0 plus 0 plus 0 minus negative 24 plus 0 minus 48. And that adds up to 72. So if I divide by 2, if I start reducing that, that's 36 22nds, or 11, try that one again, or 18 11ths. Amperes. What? That's what we had before. Define C. Well, C is the middle, is the second column, so I'm now going to use these numbers in for the second column of coefficients. So I'm now solving the determinant of 1, -6, -6, 0, -12, -12, 1, 0, 4. Not a parenthesis, it's a straight line. I'm just going to repeat the first two columns. And so this diagonal is -48 plus 0 plus 72 minus 72 plus 0 plus 0, which is -48. Which reduces down to, so you divide both by 4, and I get -12/11 amperes. Well, that's what we got before. And then D. All right, somebody tell me what the determinant, not looking for the number, what do I fill in for D? For the numerator of D, what's the 3 by 3 array?
It would just be the answers into the D column, right?
Okay, so what am I writing down here?
From left to right, we're going 1, 1, 0, -6, 2, -12, 6, 0, -12. -6, 0, -12.
That one little minus sign would mess up your answer. All right, so we end up with -24 plus 72 plus 0 minus 0 plus 0 plus 72. So we get -24. -24, divide top and bottom by 4, and we get -6/11. In my opinion, for this problem itself, getting the equivalent resistance was a much simpler way of doing it. However, we will apply this one where you can't get an equivalent resistance of anything. All right, so 3 math techniques using the 1 current per path. It is now time for mesh analysis. 1 current per loop. Anybody still writing stuff down? Okay.
I have a question.
Yes.
Can you just reiterate, I know you've already said it, but can you just reiterate the, where is my brain?
Still sleeping?
It is.
Along with mine?
It is. Can you just reiterate, like, going for the, numerator for B? My brain is just lost on
Alright.
that one.
So, if we look at the numbers here, so sort of, once I have it set up, so I got B, C, and D. All right, now I'm just going to sort of ignore those. So for the denominator, it's just those coefficients, 1, 1, 1, -6, 2, 0, -6, 0, 4. For the numerator, we have to somehow differentiate, 1, we haven't used these yet, and 2, we have to somehow differentiate between B, C, and D. So since B was my first column, I'm gonna mess with my first column. So what you do for that is you take this, which we hadn't used yet, and you stick it in for B's. So we get 0, -12, -12, and then these 2 columns are still 1, 2, 0, 1, 0, 4. For C, you got this, and now you're just gonna take this and plug it in for the second one.
Okay, thank you.
Yep. All right, here we go, mesh analysis. That's a 4. All right, so mesh analysis. What I'm gonna do is, I have 3 different loops here, 3 unique loops. I've got the lower loop, the top loop, and then the whole loop. All I need is 2 of them. I typically do the 2 smaller ones as opposed to the big one, but again, the stars. So I'm gonna take this bottom loop and I'm just gonna draw that, and I'm gonna say the current flowing through there is B. The top one, I'm still gonna go clockwise there, and I'm gonna label that C. Actually, I'm gonna label that D instead of C. In mesh analysis, if you recall back when we did it, when we solved it using the one current per path, the first equation was current in equals current out, the junction rule. In mesh analysis, you don't do the junction rule. You do the 2 voltage rules. I have 2 unknowns, so I only need 2 equations. So what I'm gonna do is I'm gonna start here, and I'm gonna go around this bottom loop. So I gain 12 volts, cruise along. I come across the 2 ohm resistor here. I'm going in the direction of B, but I'm going against the direction of D. So it's going to be minus 2B, because I'm in the direction of this current, but I'm opposite that one, so plus 2D. And then continued on, minus 6B equals 0. The second equation, I don't have to use the same loops as the currents, so I'm just gonna do the whole thing here. So I have 12. I'm going across the 4 ohm resistor in the direction of D, so minus 4D. Come down here, minus 6B equals 0. I have 2 equations, 2 unknowns. Simplifying it, I get 12 minus 8B plus 2B equals 0. And 12 minus 6B minus 4D equals 0. You don't necessarily have to line them up like this, but I did anyway. I'm gonna simplify it. This top one I'm gonna divide by 2, so 6 minus 4B plus D equals 0. And then I can divide by 2 there, so I get 6 minus 3B minus 2D equals 0. I have 2 equations, 2 unknowns, and now you've got all the techniques we did. Graphing is simpler, although still not necessarily better. Matrices, still use Cramer's rule. What the heck, let's just use Cramer's rule. So I need to get them in the right form. Negative 4B plus D equals negative 6. And then negative 3B minus 2D equals negative 6. Sorry, what? B is going to be, well, the denominator will be negative 4, 1, negative 3, negative 2. C will have, give myself more room than that. C, the denominator will be -4, 1, -3, -2. And the numerators, first column, it's gonna be -6, -6. Second column, same as before. And C, let's see, this is D, sorry, not C. D, we have -4, -3, and I'm solving for the second column, so -6, -6. The denominator is 8 minus -3, which is 11. And the top here, I have 12 minus -6, which is 18. And here, I've got 24 minus 18, which is 6. So from this, I know that B is 18/11ths, going in this direction. So I'm good here. That would be 18/11ths, that's 18/11ths, that's 18/11ths. D is, I had 6/11ths, so that would be 6/11ths going this way. But 2 has 2 different currents flowing up through it, mathematically. I've got at 2 going this direction, I have D, which is 6/11ths. And from B going that way, I've got 18/11ths. Well, if I need to get the arrows in the same direction, and when I do that, I have to change a sign there, so this would become -6/11ths to the right, and 18/11ths to the right,